Some 40 years ago, a young man walked through the doors of Michigan while going to the school full-time and working full-time. He could not enjoy any of the Michigan's offerings that makes Michigan special. But his roommate had a scholarship. So he knew the value of financial aid that could make an impact in the life of a student. And when he became successful after 40 years, he did not forget where he came from. And because he was a non-resident student, he created more than 400 scholarships to attract the best minds of this world. And he said, I'm doing this because university's doors should be open to the talented, able students who want to come here, not because they do not have money. Hannah Pavilion, who wrote her award-winning novel, We the Sinners, she wrote only after when she threw away her final year thesis when she was completing her master's in fine arts. And she was able to do so because she got a third-year fellowship, which is very unusual in this program, by a person named Helen Zell. And she said, writers should be at their desk, not at Starbucks serving coffee. And she endowed about $50 million for third-year fellowships, which is very unlike any other program that you will see in the country. Then, I really owe the university a lot for that I learned at my time here. I hope that the research my gift will support help keep us at the forefront of the global innovation and competition. This was Dr. Beister, whose name is on this building. And he gave about $15 million to support doctoral engineering students. So why is this important? Well, in 1960s, the state support was 80%, and now it's 16%. So today, our employee benefit costs are higher than what we receive from state funding. And this problem is not only important because we want money, but it's a hard problem to solve also. Because if you look at the last campaign that we had, the Michigan Difference campaign, we raised about $3.2 billion. And less than 1% of the population gave $20,000 or more, and that raised about $3 billion. So 99% of the gifts were below $20,000, and they raised about $300 million. So that's why this problem is so difficult. And I want to highlight here 3 problems that the fundraising is facing right now and how we can solve them using data science. And I'm not talking about the problems that are annual giving types, when you get calls, when you're eating your dinner and you get frustrated by those calls. That's a difficult problem also. As you have seen in 1998, the KDD Cup data, there was a mailing data that's only 5% response rate. So that's a difficult problem to solve also. But right now I'm focusing on the major giving, which is less than 1% of the population. So how can we use data to solve problems? So I think all have heard about Moneyball. But what Chinese officials did was just incredible. The simple use of data, what they did, they studied all the Olympic sports and tried to find out those sports were underfunded, underrepresented by a minority group, and offered multiple medals. And sports like different weight classes, badminton, swimming. And once they identified these sports, they trained and funded women. And they started winning gold medals like nobody's business. And did you know that 75% of all the gold medals in these categories are won by the Chinese? So I want to show one video why studying data is important and why solving them.
I want you to line up according to your birthdays. That means from January 1st to December 31st. I don't care how old you are, okay? From January 1st to December 31st, and you have to do it without talking. Ready, set, go. You have 1 minute.
So the point she's trying to make, she's Stanford's entrepreneurship director there, and the point she's trying to make is that when we are trying to solve hard problems or even simple problems, we usually take the first solution and we do not iterate enough. So in this case, one person raised the hand and everyone started following. Nobody stopped for a second and said, oh, maybe there is a better way to solve this problem. And that's the challenge as data practitioners we face, that we get lost and we say, oh, this is an interesting problem. And we get the first solution and we don't even see what is involves and what we need to do to solve those problems. Think about Microsoft Excel. We have this nice grid box where all the chart types are given. We just fit our data into those charts. We don't even stop and think, am I telling the right story? Does this information required? Is this the right type of chart for this type of data? But we get lost in what I call interesting factors. What I call interesting. And here's my big rant about interesting. Interesting is only that, nothing more. It doesn't tell us which action to take, where to go. It doesn't tell us anything. Going back to Microsoft Excel example, it just gives us a problem. We try to fit everything into that. And as data practitioners, we face this a big problem. Oh, here is a cool looking infographics. OK, that's interesting. What do I do with that? All my analysis that I have done for past 2 years or whatever has just gone down the drain because it's interesting. And that's what we need to get away from. Now, many things are interesting. For example, did you know that Dalmatian puppies are born without spots? Who cares, right? How does that information help us to get anywhere? Or, depending on how you see it, if you bang your head on a wall, you can burn about 150 calories per hour. But again, it's interesting, it's not useful. What is useful, though, is to know when to take an action and how to take that action. So this is the Blanchard bone. This is a 30,000 years old bone. When our ancestors recorded the lunar movement to track deer movement so that they could plan for their next hunt. And this is business intelligence. And this was state-of-the-art business intelligence 30,000 years ago. But where is our BI today? We are stuck. We are stuck with which direction to take. Again, as data practitioners, we are thinking about which techniques we should be using, which toolbox we should be using, rather than thinking why this problem needs solving, or how do I solve this problem. So, in our field, in fundraising, the number one problem that we are trying to solve using data is the pipeline problem. And you may ask why pipeline is so important. Because we have limited number of people who are willing and capable of giving. And again, it's less than 1% of population. So that's why pipeline is such a huge problem, is that where do we find our next prospects? How do we keep the pipeline moving? You can find an analogy in a sales problem, trying to find new prospects. So one of the solutions that we have come up with is using clustering and segmentation. So what we do is we look at our total population. So we have about 600,000, 700,000 active alumni who we have collected data, although not as much as Perry has collected. We do have some data. We would like more, but we do not have enough. But that's another problem that we are trying to solve, is trying to collect some data that we don't have. Right now we have the transactional data. We know what they did when they were students, and we know their giving history. So what we did in this case, simple clustering. We just looked at the whole population, tried to find out what are the predictors that tell us that a person could be likely a major gift donor. And we create 3 segments based upon those, and then I'm highlighting some of the key predictors that tell us, depending on what their first gift amount was and what their total giving was. And again, if you play with the KDD 98 data, you can see some of these things, that most of the future giving is dependent on their past giving. And that's again a problem, because if you have never given before, how do we predict that you are likely to? So that's why we are trying to take it from a segmentation angle rather than a classical logistical regression 0-1 problem. So we are creating these 3 clusters and segmenting the whole population and saying this is the best population you should be going after, rather than spending your efforts, because it takes a lot of money for gift offices to go visit them and cultivate and have those engagements. So we give this data, but just so you know that segmentation doesn't work always. In this case, Netflix thinks that March of the Penguins is a critically violent movie. I mean, it could be if you consider flap fighting violent. But once we know who these best prospects are, what we do is we apply one more clustering layer, because again, our time and resources are limited. We cannot send all our gift offices to Colorado, Alaska, Hawaii. We need to go where our prospects are. So what we did was, once we identify who these best prospects are, we applied one more clustering and tried to isolate those key regions. So in this case, one of our major units, we said rather than drawing the lines manually, dividing the country manually, we applied clustering and said, based upon the proximity of these best prospects, which regions should we be looking at? So in this case, one of our major units who have more than 200,000 prospects use this kind of data, and as marketing folks would call as finding micro targets. They were able to find micro targets, areas where they could allocate their resources properly. So once we have identified our best prospects, our second challenge is not our donors tweeting during a fire. That would be a very difficult problem. I don't think any data can help us solve that problem. But the problem is of knowing who knows who. Because see, in world of powerful people, connections are everything. I mean, we have also used our networks to solve problems, but especially when it becomes the key players, connections are everything. And we need to know their connections. So how do we solve this problem using data? So this is a chart by Lombardi, who started creating these network diagrams, and he called them narrative structures, because essentially it's a narrative structure. So this diagram that he drew, it was a form of art and science both. In this case, he's showing George W. Bush's involvement with some kind of a oil company or some kind of energy company. And all the notes that you see are the key players who gave him money to found that company. But what happened is that that company tanked before George Bush was able to take his money out. Obviously, this story is hard to believe. Nobody knows the fact because he was not a journalist. But the story would be even hard to fathom if you were just reading on text. So that's why this kind of a diagram is very useful to see who's connected to who. And in fundraising industry, what we can do with this kind of information is not only can we put people connected, so we can know John knows Jane, and we can get them connected, and they can cultivate them, and then they can either get engaged with the university, or if they decide, they can make a gift. But it's very important to do that. So how do we solve this problem in our field? So obviously, we do not have data on everybody who knows who. So what we did was we scraped thousands of websites. We extracted millions of entities. We connected to thousands of databases and tried to connect a network diagram just given a name. So using natural language processing, we were able to do this. And in the center here you can see we searched for Mary Sue Coleman, and all these names appeared. And we just used very simple heuristic. If the same two names appeared multiple times on different web pages, we assumed that they knew each other. Obviously, it's very simple. We have not done anything sophisticated, but it's still a tool that this kind of information wouldn't be in gift officers' hand, people who would be making these calls, visiting people. So this information is helping us to do some other things that we want to do. But obviously, as you would have guessed, this wouldn't work all the time because names are different, relationships are different. So one example of how it could go wrong, this is Microsoft's Entity Cube, and this is what inspired us to create similar tool for Michigan to use for fundraising. So in this case, you can see I searched for Rich Rogel, who is one of our greatest volunteers and donors. Microsoft thinks that he knows Jesus Christ. You can see in the right corner. I mean, he could know. He may have a connection. But the possible reason is that maybe he has given lots of donations to Christian organizations. So it could go wrong. But this is at least an attempt to acquire that data that we do not have, and essentially converting an unstructured data into structured data of relationships. And just by studying plain security SEC filings, you can see how small and how powerful the world of powerful people is. So this website is called theyrule.net, and here you can see the board of directors of JP Morgan Chase are everywhere. You can see all different kind of Harvard Business School, General Dynamics, Berkshire Hathaway. So you can just see how powerful that network is. This is completely based on publicly available data. So once we know these relationships, we come into our third big problem, and that is matchmaking of interests to their giving areas. So we need to find where these matching interests are. So one way to solve that problem is using something like segmentation. So in this case, Amazon thinks that when we are trying to seek wisdom, we are also seeking weight loss. So it's kind of an interesting paradigm, and unfortunately, coming from a country where we solve world's credit card and computer issues, I do not possess any of those, neither the wisdom nor the weight. But we can still use that kind of segmentation to come up with some market baskets. So if you have given to some unit that we can hypothesize similar to people how do their purchasing, they give data they give similarly. So in this case, what we have done is we have found one unit, and we say, okay, so we know that this person gives to athletics. They're also likely to give to law, engineering, and business, or they're likely to give to med and arts and library. So what this does is it opens up the constituency base. So think about museums. They don't even know who walks into their doors, let alone capturing their data. So who are they going to ask for next when they want to raise some money for some kind of an art piece? This opens up a door because we can say, oh, we know your previous donors have given to these different areas, and now you have a different mechanism to open up the constituency. So I showed you three big problems: the pipeline problem, the connections problem, and the interest problem. Obviously, as you have seen, I'm confident there are much better ways of doing this. This is at the end, a couple of administrators trying to solve this problem. We are not researchers. And I'm equally confident this room full of people, smart people, can help us solve this problem much better. And although some of you may not be still convinced that fundraising is important, you can take it as a data mining challenge because the response rates are so low. Less than 1%, less than 5% if it's a mailer. And I'm confident that you will be able to help us with some of these solutions. So with that, I want to say thank you.